I'm Ron Varnell, and welcome to episode 74 of September Song. In this episode, we'll take a look at the James Webb Telescope. As an overview, the James Webb Space Telescope is a platform that floats around about 1 million miles out in space. The telescope on the platform is 6 times larger than the Hubble telescope and is designed to see the farthest galaxies. That's a long way off and a long time ago. The light we'll be seeing coming from those distant galaxies left there about 13.5 billion years ago, not long after the Big Bang. So I had this theory that if you have a telescope that can move instantly from one place to another in space, and if the telescope is powerful enough, you could look back at the Earth and observe history. You could adjust when you are looking back by moving your telescope closer and farther away from the Earth. Just a thought. Back to the story. The telescope is named for James Edwin Webb, who was the second appointed administrator of NASA and served in that post from 1961 until 1968. He served under Presidents Kennedy and Johnson. The telescope started the construction process in 2007 and cost almost $9.5 billion to construct. That's a B. The project is a shared mission of NASA, the European Space Agency, and the Canadian Space Agency. The heart of this telescope is its primary mirror, which is made up of 18 hexagonal elements made of gold-plated beryllium. These elements combine to make a 21-foot diagonal mirror, much larger than Hubble's 7.9-foot mirror. All this equipment is so large that it must be folded to fit into the launch vehicle's bay. It will unfold like origami when it reaches space. Unlike the Hubble telescope, which observes in the near ultraviolet, visible, and near infrared spectra, the telescope will operate in a lower frequency range from long wavelength visible light through mid-infrared. Now, this will enable it to observe high redshift objects that are too old and too distant for Hubble. The telescope must be kept very cold to observe in the infrared without interference, so it'll be positioned in space near the Sun-Earth L2 Lagrange point. That's about 1.5 million kilometers away. A large sun shield made of silicon and aluminum-coated material will keep its mirror and its instruments cold, below 50 Kelvin. It needs to be cold to operate effectively. Observing in the infrared spectrum is a key technique because it better penetrates obscuring dust and gas. Now, this allows observation of dimmer, cooler objects, since water vapor and carbon dioxide in the Earth's atmosphere strongly absorbs most infrared. Ground-based infrared astronomy receives overwhelming light from the subject being observed. The James Webb Space Telescope will be able to observe an exoplanet's atmosphere. It will be able to seek out any traces of life-bearing gases. The European Space Agency's Ariane 5 rocket containing the telescope started its journey on Christmas Day. Unfortunately, we'll have to wait 6 months before we see any images. 6 months is just too long to wait for images. So I have a solution to that. What I do is I take this camera, this Polaroid camera, and duct tape it to the space platform. And then you can get your pictures in 60 seconds. Of course, you have to have some kind of a gizmo to wave the thing around so the pictures will develop quicker. I don't have that, and besides that, the dang space station's already gone. It's me $1 late and $1 short.